haven't been in this server in probably 5 years. But I a couple weeks ago I came on to I think it was in politics, and someone on there, we were talking about the Walter Bislin website was down, and I think we were talking about like how much curvature you could see at different uh, at different altitudes, and I got frustrated because the Walter Bislin site was down, and so I decided to make some visualizations, uh, um, and so I made a little website that I could share with some things.
How come you need Walter Bisling's website to
Well, now I
know
don't.
how much globe there should be or see the globe?
Now I don't.
Yeah, you made your own website? That's kind of cool. Let's see it.
I did. How do I post it?
Voice
What
chat,
do
go to the
you think
bubble,
is the
and
best-
then live stream voice text.
What do you think is the best evidential justification of this curvature that the likes of Walter Bisling are claiming exists?
Well, so one of the things that I found, so I did one that was like it was specifically to be a airplane, like a view from an airplane. And
You think
I'm seeing that, at least the way, if I have things set up correctly, that curvature should be visible under a globe. Curvature should be visible slightly from an airplane. And I didn't think this before.
you ever been on an airplane?
What is that?
Have you been on an airplane?
I have.
Did you see the curve?
I did not. But what
does it make? What
what I
sense
found
does
was,
it make to say? What sense does it make to say? According to this website I just built, it should be possible to see the curve from the plane if there is curve. But I've actually been on a plane and there is no curve. You've answered your own
it's very
question.
very slight. It's very slight, but it would be perceptible to if you took a picture. And a lot of the stuff that the website does, I'm trying to get as close as I can to like what different types of cameras would see.
But they're not.
And
But I mean, that's a roundabout way of doing it then, because even if you want to make the argument that, oh, we could take a picture and we could put like a straight edge on the picture and we could see if it deviates slightly, then you're just going to get into the argument of barrel distortion and the window that you're looking through.
right,
So then we're
right,
inevitably going to come back to, okay, well then what surveying techniques have been used on the ground to evidence that what you're saying you're seeing here is curvature commensurate to a 39-59 mile radius ball is actually detectable when measured in reality? Because the high altitude stuff can be argued either way till the cows come home.
So what I tried to do is build all of that into the visual. So if you look at the airplane one, I include refraction in the airplane window, and then you can also select
in the airplane window.
FOV, the FOV and the like the projection type of the camera, and see what different effects would have, and then you can change whether it's a flat or a globe Earth.
All right. But outside of simulation and all of that, why has no one been able to detect this curvature through measurement of the surface?
Well, I think so. What I'm seeing with this thing that I made is that there's a certain curvature that the globe model would predict, that the globe model predicts from a plane. And when you look at images that people have taken from airplanes, on good days with good visibility, it matches the curvature that the globe predicts.
Stop the
and
cap.
It does not.
Well, I would say that's very debatable, but if you're saying that, then you could also say, well, the globe model predicts a certain curvature over a distance on the surface, let's say 10
Right.
miles over a lake. That'd be what, 66 feet-ish. So why can that not be measured or detected?
I mean, that's a whole other conversation.
No. That's not a whole other conversation. That's the
Yeah,
exact thing you're trying to
Right.
argue. You're trying to say you see that 66 feet over
Yeah.
10 miles curve from a plane, So if that were the case, why can it not be detected on Earth?
Well, that's I don't know. It's sort of like we have to compare we have to take all this evidence. So
No,
like,
you just have to be able to provide measurement of it on Earth in reality, or concede that it's not measurable, not there.
yeah, I see what you're saying. I think to me, what the fact that the curvature is of that's seen from planes and with good
Well, no, but you can't say
good
the
atmospheric
curvature is
conditions.
seen from planes, though, because I've just pointed out that that's not measured in reality.
I mean, we can look at pictures of like I'm we can look at pictures of people who've taken pictures of the horizon on planes and see which model fits it.
Right. But then we're just going to come
Let's
back
do
again
that.
to then why is the curvature, that 66-foot drop over 10 miles, why is that not detected? If
Well,
what you're
there
saying or
are
showing in these images is that 66 feet over 10 miles, why, when we go to the ground and someone tries to detect it, is it not there?
I mean, this is an argument that I mean I've had it before, and it's a matter of like we have to take all of these pieces of information, and there are obviously globers who have taken measurements that they believe to have shown curvature,
All or nothing
when they're on the
policy.
ground.
Right. But is there actually, well, people can claim that, but is there,
Right.
well, which measurement would you refer me to if I'm saying who's measured that 66 feet of drop in reality?
That's
Which
the question.
measurement?
Like we have to look at all of these pieces of evidence, and to me,
Well, you said
this
you've
one
been
from the
here like
plane
for
is
5 years.
another
You were
piece
here
of
5 years ago. So in that 5 years, have you found any measurement of that?
No, I mean, I dropped off the debate for a while, and I just got
Right.
interested in it again. But I've
Well,
not.
well,
I
I'll
mean,
tell
I've
you,
seen.
we've been here the whole time, even
I was
longer
looking
than
up
that, and no one's measured
actually
that.
when I was looking at like when I found Walter Bislin was back up again. He did a measurement on I think it was the Bedford level. Um, uh, that was very exhaustive. Let me see if I can find it.
Well, the Bedford level, that would just be level, level water.
I
And
guess that's the
that was actually the measurement done by Robotham at the Bedford level, which started this whole thing in the modern day again, because he wasn't detecting that curvature either.
right. Let me find the
I've posted some of the material from J. Tolan Media 1 and also from a pilot, SR-71 pilot, who says he could see the whole of the West Coast, California, from his aeroplane, no curvature. Okay, so there you are. Three videos there for you. You can look at. They're not long, and they're quite concise. All right.
Let me see.
From the horses' mouths.
I'll be right back.
Thank you very much, Psyclone. Well done.
I'm not as I want to make some simulations like you on this website that try to handle this whole refraction and laser tests and visuals and stuff, but I haven't made them yet, so I don't know. I'm not read up on the topics, but like the one that I can speak for is this airplane one that we do expect to see a particular curve.
Yeah, why don't you post one of those? Because when you're looking out the window of an airplane, you're seeing a city beneath you.
Yeah.
At most, sometimes parts of a city. And you're seeing curve as well.
Yeah. Can you explain what you mean?
That's what you said.
So like it's easier. This is what why I made the website.
Can you explain what you mean? You said you see curve of the Earth.
Right.
And you also agree that all you're seeing out the window beneath you is just a very, very small portion of the overall Earth.
Right. This is why I made the visualization. Like if you go to the website, you can see
No, I'm talking about your original claim that you know the Earth's a ball because you've seen that airplane window.
That's a piece of evidence that gives credence to the.
Yeah, post one of those images. I'd like to see that. I'll be back.
Okay. Someone mentioned Jay Tolan's. I think that I actually looked at some of his videos. Was one of these Jay Tolan's video? Let me find one.
Yeah, you were asked to find a material from an aeroplane window that you've seen, apparently. That
Sorry.
you've seen. Yeah, that you've seen, because Jay told me that he uses a Canon camera, infrared lens, and the videos I've posted show you what you can see without the glare. So it cuts through the infrared, cuts through all the noise, they call it. All that glare is called noise, and you get a sharper resolution image. And he was able to see up to 1,000 miles.
Okay, yeah.
Hudson Bay, 500 odd miles. Yeah. So, and then the Colorado, Rocky Mountains, 35,000 feet above the earth. That's what he could see. I've traveled by plane many times, and what amazes me most is the infrastructure. What man has actually created on this earth is what blows me away. And then now that I'm a flat earther, how flat everything is on top of that. Wicked. Amazing.
Yeah, the distance things, that's something I want to look at too, because I watched a couple of his videos, and he gets really in depth with how far he sees, and I want to see, like, I want to maybe add a thing where on the crosshair of on the website when you're visualizing, you can see.
Yeah, the only way you could really debunk him is to actually go out and replicate that. That's the only standard, really. Your critiquing here is not really going to work, really. You're going to have to go out in an aeroplane with said equipment and make that same observation, or somewhere similar anyway, and start showing us how he couldn't have done that, because here I am on a plane with my equipment, and this is what I'm finding. Okay? It's got to be done that way. Because that's what he's done. He's taken the time to do that. And we're looking at it and we're thinking, amazing. Okay? Now, and that goes with what we find. We're measuring Earth flat, you see. That's what you must remember, that we're measuring Earth flat. So if you want to say there's curvature, then you're going to have to prove that, show us what you've got. And there's Neil deGrasse Tyson has stated that you wouldn't be able to see curvature from 24 miles off the Earth's surface. That stuff is flat, he said.
And I mean, that's the kind of stuff that's because what with the visualization that I made, I'm seeing that we should definitely have visual curvature from planes. I'm still trying to find. I'm looking through Jay Tolan's videos. I want to get a screenshot.
Apparently, even from the ISS that we know is not up there, when they show the curvature, they show you something that's incorrect, because what they show you is far too much curvature, actually, from the ISS and the images they give us. Apparently, we should only be able to see 3% from that 250 odd miles from the Earth's surface. We should only be seeing 3% of the Earth, right? But they show us far too much curvature there. Right. So there's discrepancies all over the place, right?
What I found when I do the math in this visual is that we definitely should see curvature. So whoever was saying,
but can you not apply the maths to the surface of the Earth? Can't you do that? That's the standard, isn't it? To actually go to the surface of the Earth and use your methodology and measure the surface of the Earth. That's going to be the most accurate, isn't it? At the end of the day, because you haven't done that yet. You haven't done that yet. That would go a long way to helping you understand how the curvature is not there. You haven't made that measurement yet, have you? Have you made that measurement?
But I mean, if I post,
I didn't hear your answer. Have you made that measurement?
I haven't personally made a
No, well, then that's what you're going to have to do, then, aren't you? You're going to have to go out personally and make the measurement, because all of us here have done that. See, when you've gone out and actually endeavored and spent time trying to find that curvature, it strikes home much harder than all the critiquing and all the maps that we have. That's fine. But you've still got to go out onto the surface you live on and check it. That's where it's at. That's the place.
There's value. So, like, even in Jay Tolan, he's a perfect example. He does a lot of work after his videos, analyzing them and comparing them to maps and things. And there's value in, even if looking at someone else's observation and trying to interpret it and see. So I just posted a link to a video of Jay Tolan's where it's one of his pictures on a very good day with one of his infrared cameras, and the curve that's seen there matches the curve that my visualizer has for
unfortunately, I'm not going to be accepting that as a flat earther. What I will say to you is this: I will accept you measuring curvature. That I will accept. You spending time actually going out there on the surface of the earth, doing what I've done and what all the other flat earthers have done, and then bring that stuff to me. I'm willing to look at that. That's what I want to see.
I should. I do have a link.
Yeah, that's what I'm waiting for. Sorry?
I do want to go try some.
Yeah, please do that, because that's all I'm going to accept as Jin CBR1. That's the standard I put down upon you. Go out, measure the curvature, show me that. I want to hear you critiquing a man of integrity and his work, and then some other video you've watched that states you should see curvature. Not interested in that stuff. That's not my interest. I have no interest there at all. I'm interested in what you can do.
I was complimenting him.
Yeah, because that's very important.
He's done some. I mean, he's done a lot of work. He's put a lot of work and thought into these.
He spent a lot of time and money and effort. You haven't done no such thing as yet. You're doing a lot of effort critiquing, but you haven't done anything yourself. And that's easy for you to do, because the outdoors, just open your front door. There's great outdoors. Get out there. Plan a weekend. Take some friends. Rent it. Don't even buy equipment. Rent equipment if you need it. Go rent the equipment, so you don't waste any money, because you may not use the equipment ever again. So go out and make a good day of it. That's what you've got to do,
I agree. I should have done it.
Exactly.
What are the if I tried to do measurements during the fall or the winter over like a lake? I live in the Midwest. What are there any tips?
I would suggest that if you can, do it through all the seasons if you can, in different places, and then see what results you get.
Yeah.
Really. See, that's what I would suggest. I mean, I can critique Jay Tolan and stuff because I've gone out to see the earth and I've seen it as flat. You haven't done that yet. So to be critiquing when you haven't even checked, because actually checking drives home the fact that the earth isn't a globe. That's why I'm suggesting you do that. Okay? It's a must do for every person on earth. Must do. That way
I made some. I want to make more, but I wanted to show the things that I've made. So the other thing one of the other simulations that I've made so far has to do with something that I didn't see when it wasn't a common argument when I was here a while ago, but there's this very reflective lake in Bolivia.
Yeah. And specular highlights, they call those, I think, where you're seeing a reflection on the lake that is a mirror image, which proves that lake is dead level, because if it wasn't, then the image would be distorted. Yeah.
Right. So what I did is, the simulation I'm using, it's a ray tracer. And so I actually just made a mirrored sphere and then a layer of clouds on top. And you can change the height of the clouds and you can change the size of the sphere and see what distortion you see.
Yeah. In all my life, I've always seen distortion of any image. It could be a car bumper, a chromed car bumper. As I'm cleaning it up, I see my image, it's distorted. It doesn't matter what curved surface I've seen. I've never seen a perfect mirror image ever. Not from a curved surface. Never in my life. A mirror, that's the back side of the mirror, that's chromed. The mirror itself is showing me lovely picture of myself, but when I look on the back of the mirror, it's distorted because it's chromed and it's got angles and curvature. I don't see a perfect image of myself. I see a distorted image on any curved surface. This is what's so good about God's earth. Simple. The lies just don't happen. It is what it is. A curved surface will never show you a perfect image of yourself. Can't, because the surface is curved.
So
that's what he was about to say is, yes, it's a mirror image, but we would expect it to be in a mirror image on a ball.
So not quite.
Wait,
so
aren't you? Yeah, close enough. Aren't you? You're the guy who said, but you started by this whole thing by saying you saw it curve from an airplane.
I've never taken a picture and like compared it to this from an airplane, and I think
you're the same guy who said his best Earth ball evidence was you've seen it from an airplane, right?
No, Hawk. I got him to clarify on that. Remember, he said he'd never seen it.
I had to go away. Okay, I missed 20 minutes of it. I shouldn't have. Okay.
He said he'd done a simulation which said, according to the globe, we should be able to see it from a plane. And then I said, well, have you been on a plane? And he said, yes. And I said, well, did you see the curve? And he said, no. So I said, well, there you go then.
Oh, okay. Maybe I'm sorry. I had to go away for a few minutes.
No, that's fair, though. It's a fair assumption. The way he's arguing, you would think he has seen it from a plane.
Yeah, I feel like we're getting back to that.
Though I should clarify that it's harder to say. It's harder to say like you should visibly see a curve, because then you need to get into
also that's just not true, because we've all been on planes and you can't see the curve, so we know that's not true to begin with.
So I should clarify that my claim isn't about being able to see with the human eye, but with a camera. If you take a picture and if you know
even with a camera you don't see the curve.
Camera and the
and that's going against the globe model again. Like, so you're even at odds with what they're actually telling us about this globe in terms of what we should see.
I disagree, because the simulation has all that all of the like math for what you should see baked into it. So if there are people claiming that curve,
but that's where I was that's why I was getting to the point where what you see from the plane is a city beneath you or a portion of a city.
Okay.
And you're seeing the curve of the Earth when you pull out your camera?
City or a portion of the city? I mean, it depends on where you are. Maybe there's a city.
Yeah, you said like a 35,000 altitude flight. 35,000 feet altitude flight.
I don't know what you mean when you're talking about like a city.
Goodness gracious. What do you mean? A city is where people live.
So yeah, you could. I'm sorry.
So all I'm trying to get you to realize is you're seeing such a small portion of a particular state, let alone a continent, yet you're seeing the curve of the Earth. Well, you have a lot of land masses and oceans to fit into this ball, remember?
Right. But
tiny earther.
Right. What I'm saying though is that even though it's not what we expect when we think like, okay, I'm like not that high over the globe. When we do the math and visualize what it would look like, we should see a very slight.
Who is we? Who is we?
Me. I mean the math in this visual.
Which visual?
I'll post the one that I'm talking about.
So strange. So Entmonk, how do you think it was?
The code is open source, so you can look at the code for each of the visuals to see.
Yeah.
Can you think that Neil deGrasse Tyson, who is the PhD planetarium guy, they put him on TV, he hangs out with the astronauts. How do you think he messed it up so bad where he's saying, no, you can't see curvature from even 120,000 feet? Do you not think that's a bit odd?
I think the realistic answer is that he just did it wrong. I think that a charitable answer was that he was talking about like where you could visually discern it with your eyes. But the claim I'm making here is particularly about cameras that you could take.
But they had a camera. It was the camera that he was talking about where he was saying, no, this is just a portion of the lens.
Right,
but that's what I'm saying though. So how is it that they've messed up so badly that they've got this guy who's PhD planetarium director, he's on TV, he's teaching children all across the earth, he's hanging out with astronauts, but you think he can't do the basic math to figure out when the globe should be seen or not? Like, that doesn't make sense.
That's a good question. I don't. I mean,
has anyone called him out on this? I mean, have you brought this to the attention of the people, NASA? or him? Like, who's calling him out on this? Are you the only one, or what?
Sure,
Is this under review?
I don't know. I would say that this is kind of like a side thing. If you the math sort of will stand for itself. The code is
math.
there.
You keep just saying the math. What is the math?
Yeah.
What are you using for a coordinate system?
So I'm just using this visual is just a sphere. It's just a camera.
How is the image being created?
With ray casting.
In what coordinate system?
We don't really need a coordinate system.
You don't need a coordinate system, so you're not using homogeneous coordinates.
What is that?
Oh, Jesus Christ! So you have no idea. You don't have a fucking clue about 3D rendering, is what you're telling me.
Can you explain it? Maybe I used it and I didn't know that.
Homogeneous coordinates, a coordinate system. It's a generalized geometry coordinate system for creating images, where you have a projection plane and then you have a 3D scene, and the points in the 3D scene get projected through points on the plane, and the plane is your image.
Yes, that's what I'm doing. Yes, so.
Okay.
Yeah, that is how we're.
What radius value are you using?
So how does that predict what a camera sees versus what a human eye sees? Because what's the difference? The difference between a camera and a human eye is the diameter of the lens.
So can you
the diameter of the lens, right? The human eye is like 10 millimeters. If I whip out a P1000, it's something like, I don't know, 4 inches or something. The diameter of the lens. I don't know why you don't understand this. Is this your app?
Yes, I made this. I guess I'm just trying to figure out what the.
Did you use like pre-made libraries or something?
This is all from scratch. This is with WebGPU.
From scratch, and you don't know the coordinates you used.
Well, I mean, I hadn't heard it defined that way before.
In homogeneous coordinates, it's a standard in all fucking 3D graphics.
I just did it kind of just from first principles kind of thing. I don't know what all of the like ways of doing it is.
Euclidean geometry, then? Like X, Y, Z?
Yeah. Everything is in Cartesian coordinates.
In Euclidean geometry.
See, you've also got stuff like, I can see in your code, you've got use flat Earth, and the description is toggle between spherical Earth and infinite horizontal plane.
Yes.
So, I mean, this is.
Well, let me go.
If you've done all this yourself, fair play for the effort, but this is all just fantasy, dude.
Yeah.
Like, what radius are you using here? Like, I don't actually see a number for the radius.
There's a constants file that has the radii of that I'm using. I'm using the Earth radius in meters, whatever that is. I don't remember off the top of my head.
Right, but see, that's what's in contention, because we would point out that you don't actually have a radius of an Earth, and so this would all be, theoretical imagination.
This would be like testing to see if, using the radius that they give us, what would we expect to see? That's what I'm trying to achieve.
No, right. Not what we expect to see there.
But if you're showing any curvature in that, then that's not what we expect to see, because we know what we expect to see when we fly above the Earth, and it's no curve. You already said that. You didn't see any curve. None of us see any curve.
I didn't see any curve with my eyes, like perceptibly.
But your visuals on this are showing a curve.
Yes. Yeah. No,
which isn't what we've seen.
By the way, if I may quickly.
So how can you say this is what we would expect to see, even though we don't see it, and then you're going to depict a curve that isn't seen and say this now makes sense? Like, the whole thing doesn't make any sense.
If I may, and Monk, sorry, gentlemen. Where's your code? Where'd you post it?
It's linked in the website. On each one, there's a link in the top left.
The link is at the bottom. What's it written in?
It's written in TypeScript and in WebGPU shaders.
Okay, TypeScript.
What I want to know is this: how did you get from Euclidean geometry to projective geometry? How did you convert from one to the other to create an image?
What we do is we have the plane, like you were saying, where you have a pinhole, like you have the camera location in Cartesian coordinates, and then you have this plane, or for the fisheye lens, we just go out based on the angle projection, and then we trace that ray through the plane window and refract against the layers of the plane window. And then that final ray, we check to see if it hits, we just analytically check to see if it hits the sphere that's below. And then we return the color after that.
Are you like reinventing the wheel or something? Maybe. This is a I'm serious. This ain't like a standard way of like doing a 3D engine or anything like that.
It might be, yeah.
It's a standard way for ray tracing, but like, how did you get? You said you use Cartesian coordinates X, Y, Z. How did you get to the plane in the image it creates?
Like, how do I create?
Because you have the 3D world, right? And then you have the plane, right?
Mm-hmm.
Ostensibly, let's say that's the eye or the camera sensor, right? The retina or the camera sensor. Let's assume that to be true, even though it can't possibly be true. But let's assume that's true. How do you go from a point out in 3D space to a point on the? Did you say the lens? You were using a fisheye lens?
There's a fisheye lens setting, yes.
And that's projecting it onto a virtual sensor?
Yes, yeah. We use the, well, it's different for the fisheye lens. For the fisheye lens, we just go straight from the projection geometry, where the angle of the ray that we look for is just based on the fisheye projection equation.
Also, where have you gotten all the math for the window properties that you're calculating here? You've got the thickness, you've got the index of refraction, you've got the outer pane thickness, the air gap 1 thickness, inner pane thickness, air gap 2 thickness, scratch pane thickness, all sliders. What math were you using to program the refractive properties of a view from an airplane at however many thousands of meters? Which would also take into account that's not taking into account air conditions, right?
That's true. Yeah, I haven't added air conditions yet.
So where's that math
I wasn't
coming
able to find great sources for like what airplane windows are. If anyone has them, I would be happy to add them. So what I did is I basically we have those layers, and then the most common material, we have the index of refraction for that. But then just to demonstrate kind of what an extreme, what an extreme level of refraction would look like, if you use the simple window model, then you can just select a single layer, and then the width of that layer, and then the refractive index, and see what it looks like. And
have you treated the window as a flat window or a curved?
It's
and
a curved window.
Why do you got 35 millimeter sensor, dude?
It's a slider.
Yeah, I know, but like a 35 millimeter sensor would be fucking gigantic. Sensors are like tiny, dude.
Oh, the size of the sensor.
Yeah, that's the actual place where the image is being created, is on the sensor, right? So when I move your slider, all of a sudden it stops being a curve, you know.
When
I wonder why that is.
I cannot believe
the
that.
advanced camera and the advanced camera things.
Yeah.
This is a crazy
So
simulation.
that's going to change the the size of the sensor. You can move it down, I guess. What are the common sizes of sensors that you'd expect?
It's like the size of your thumbnail.
Yeah. Hopefully, if the ranges on that are not accurate,
Let's see what an A4 sensor is. Oh.
How long did it
Also,
take
Judy,
you to make? How long did it take you to make this? Could I ask? How long did it take you to make this simulation?
I started working on it a couple weeks ago after I was in here talking to, like when that first started.
So it's taking you a couple of weeks
get some water real quick.
to make this.
If I
I mean,
may add,
obviously a lot of effort went into it. I'm just kind of surprised that, you know, you've gone to this much effort for this, but you're not concerned about the lack of empirical detection of this curvature that you're trying to simulate in reality.
And if I may point out, dude, checking your constants files under core utils, and I don't see anything about Earth's radius, Earth's circumference, Earth specific any geometry or any geometric characteristic. Is it one of the do you compute that on the fly with a slider or something somewhere? Rather.
Well, it said on row like 400 or something. It's something about the spherical radius in meters, but it doesn't actually give the number there. But I guess that's built in somewhere under the code lines.
Yeah. Well, there's several files, right? So in the file source/core/util/constants ts, where I would have thought that he would have put a radius because it's a fixed
value.
Is under
airplane. This is under airplane window.
Okay, source.
Under
scenes, I guess.
Scenes, airplane window, line 402 or 403.
I'm also back. If there's any questions, I can.
Are these working sliders, dude? Do these like actually work, or are you adding features?
System bodies. Okay, thank you. Got it.
Which sliders?
Yeah, index to refraction sliders don't seem to be working. Inner pane thickness don't seem to be working. Outer pane thickness, air gap thickness, air gap tooth thickness. None of these seem to change the image.
That's kind of what I found is that the panes are so thin that it's basically imperceptible, the effect that it has on the angle of the light. But I kept it in there just just to test it. But the reason those sliders are changing the values. They really
also, I meant to ask as well, you've got reference to a cylinder surface. We've got distance from camera to cylinder surface, radius of the cylinder. What's that referring to?
Where is that?
That's lines 404, 405 under the airplane window.
Which file?
Airplane window under scenes. You're talking about cylinder radius underneath the sphere radius. I was just wondering what you were referring to there.
Okay, yeah, this must have been, I think I repurposed this part from something else. Yeah, where is this coming from?
Okay.
I must have copied this code over from something else, but this is just an issue where the variable is named incorrectly.
Also, do you think it would be an issue that you've used?
Cylinder. Never mind. The cylinder is the plane. I'm just rendering the plane as a cylinder.
Right. Okay, I did wonder if that was maybe what it was supposed to be. Okay, but also, so you've got flat Earth as an infinite horizontal plane. Is that what you think we're claiming?
No. It's just the way that to make it look flat. The way that the ray casting works is just that it's you take the ray and then you just analytically figure out where the hit would be, and I guess I don't know how else to do it then other than just make an infinite plane. But obviously beyond a certain distance, I mean the angular difference between the sizes of the planes are going to be, they won't matter.
Okay, interesting. Well, I mean, fair play. At least you're putting in some effort. That's more than 99% of the globe believers are doing here. So I'm glad you're engaging with the topic. What I would suggest, though, is not to try and get into simulations of what the globe is claimed to be, as much as seeing if the globe as it is claimed to be is actually showing itself in reality when people attempt to detect it.
Yeah,
That's
I
the way you
definitely
need
want
to
to make
work.
some measurements. I still have not tried measurements myself. What I'm gonna do though is I'm taking a plane soon, and hopefully if conditions are good enough, then I'll try to take some pictures,
Okay.
and see if it matches. But yeah, so that's the plane one. I also made the mirror sphere ones, which is kind of attempting to address the mirrored surface things, because I was curious too when I heard this argument, what different sphere sizes would look like when you mirror them.
But they're only
And
but they tell us that they know what the size of the sphere is, right?
right. So yeah, if you pull the slider up on the mirror surface one, that max value is the claimed Earth radius. And if you zoom in really far, you do see some areas where I think it's either that things in the sky don't appear mirrored at the very far distances. And so if you're able to get a mirror, like a salt
It's kind of
box, or
difficult to tell with the pattern that you've put on it because it's like an irregular pattern. It would almost be better to have like a uniform pattern to make
that's
Those
true.
patterns are supposed to be clouds.
Yeah.
They're supposed to be
If
clouds.
you can change the scale of the clouds to make it a little easier, and if you change the density of the clouds, to make them kind of so there's fewer to deal with, and it's not as visually cluttered.
Okay. Well, this is a trip.
He still thinks the Earth has a radius. That's interesting.
Yeah, it's baked into. But here's the real kicker, though. By the way, just want to point out, dude. I'm looking at your code and everything. Good work on this. This is really clean, and the app itself is very, very smooth. So I can congratulate you on that. Okay, Cyclone was saying, Cyclone was saying, obviously you put some good work, you put some solid work into this. So kudos to you on. Okay.
Thank you. Yeah, it was a blast. I always learn so much when I get into flat Earth. I had never used WebGPU to this degree before, and WebGPU was very fun to learn. So I'm glad that
this spherical mirror one is like an acid trip. Playing with these sliders. It's like an acid trip. Watching these.
Moving I was actually kind of scared. I was almost considering putting like a epilepsy warning on the on it, because when you see those things, it flashes at you.
Yeah, when you start like messing with the Earth radius, like decreasing it and increasing it, that's a real trip.
Yeah, I found it in the code there. You didn't. Yeah, you had it under a different file, so that's there. And yeah, it's in meters, 6 point something times something to the e to the 6 or something like that. Yeah, it matches out to 3959 miles there. It's all good.
Do you know what I like about this?
You can change the unit if you on certain ones. You can change the units if you'd like.
You want to standardize it in metric or whatever, and then convert. It's not a problem there.
Yeah.
You know the good thing about this, and it's something that I've thought about for a long time, is like if we made a video game of this topic, basically, and you just made it a fairly rudimentary, you'll either spawn on a flat surface or a curved surface, and you're given some straight edge tools, let's say something that simulates a laser or a line of sight with 2 points that you can make. Everyone would be able to figure it out super quick, because if it's a video game or something like that, people's logic would actually work. It's only when it gets into the real world that people tend to avoid what's obviously apparent here. But this is almost like an example of the world you'd be building, which is these infinite planes or a ball with a radius of a certain size. This is almost the start of our flat Earth video game, end guy. So maybe you can help us out with that.
Yeah, I don't have a lot of faith in this ray casting to perform super well with lots of geometries, but who knows?
No. We just need to use the 3959 mile radius geometry, and then we could assume the infinite flat plane that you mentioned before, and it's like you're dropped onto the surface, and both of them might look flat to to your initial observation, but you can plant, let's say, an observer at one point, and then you can move him across the surface to, let's say, 20 miles away, and you can swap between the two views and see what it is, and say, well, if I'm not seeing the laser coming from that initial point that I set up, and I can see the laser going over my head at this distance, I can say this map that I'm on is a sphere of this size. But then if it doesn't do that, they would say, okay, well, this is a flat surface. And I just imagine that a lot of people would intuitively get that right because it's a video game and there's none of the high stakes involved like what we're talking about here. Because people's logic and reason tends to work well when it comes to a video game, but when it comes to reality like this, they just can't get it. But anyway, interesting stuff. Thank you for sharing.
One thing I'd like to point out, maybe you already spoke about this and I missed it earlier, so forgive me on that, but I'm looking through the parameters here, and I see you've got a index of refraction for the window, right? You have that supposed index of refraction for the medium outside, because a lot of people argue that, light is bending and shit like that through the medium of air, depending on the conditions and all that. Do you have that baked into this somehow anywhere? Like, have you factored that as a thing to account for?
I'm not in the plane one. I'm not doing like continuous refraction through the atmosphere. I'm not doing that.
Okay. Yeah, I figured not there. Like, how do you even model that, right?
I do, although I've made some drafts to try doing it, but it's difficult because the web GPU or like the GPU does all float 32s, and a lot of the like really far distance things, I almost would just rather use like more precise float. And so I've been experimenting with that, but I haven't published it yet.
Okay, no problem. But the other thing I want to ask though is, if I'm not mistaken, this window that we're looking through, it itself is curved, right?
Yes.
Okay. So how do we distinguish between the results that we see, the curvature that we see, being a direct result of the window itself being curved, especially if you're, considering a window index of refraction and all that, as opposed, so the window being the responsible agent in creating the apparent curve, as opposed to there actually being curve outside.
So that's what I tried to do with adding this whole window refraction thing, is if we can get an accurate enough model of what light would do in a window, then you can like turn on the flat Earth mode and see what the result would look like through the window if it was a flat Earth, and then you can turn it off and see what it would look like without. But the underlying the basic result that I've found after implementing the refraction through the window is that it's for a normal, like for the model that I have for the thin materials, it's a very, very small impact, imperceptibly small impact on the image result.
Okay. And then what are you actually comparing this to, as people were pointing out before, like the real world observation? Like what are you comparing this to say, oh, well, this is accurate because it actually matches X? Like, what is X?
Right. So I posted a link to Jay Tolan's video, and he has a whole bunch of these, and I haven't gone through all of them, but what I looked at some of them, and in some of the images where the horizon is very clear and there's not a lot of clouds, those are the images that I was comparing them to.
Okay. Yeah. Okay. Gotcha. Thank you.
The only other one that I have up right now, and I will make more, and if people want to want me to make some certain ones, I'd be happy to. But the other one I made was a simulation of gas particles. Basically just kind of talking about what whether or not gas needs a container, that kind of thing.
Right. Could you simulate a collection of particles with gas particles without a container? Could you do that simulation?
Yeah. So I guess it depends on what you mean. So kind of what I was intending with this simulation.
Well, it's very simple. Just listen to the words. Listen to the words coming out of the speaker. A collection of gas particles without a container.
Like, so I know what you're saying. I'm just trying to kind of explain what my intention was.
Okay, more than one gas particle in relative vicinity without a container. How is this, like, how does this require another 30-minute elaboration on like what you did and Web 3D
okay, sure.
and the constants file, like a collection of more than one gas particle in relative vicinity without a container. Simulate what's going to happen to that system of gas particles.
You could.
Are they going to coalesce into a sphere?
If Newtonian gravity is applied, then yes.
Right. So you could have different switches, right? Turn it on, turn it off. Do maybe some double in Einsteinian with a little bit of tensor calculus, right?
Yeah, sure.
I love tensor calculus.
Who doesn't?
I love it, man. I breathe it actually for finance.
Yeah.
What is tensor calculus?
Of course, in your wet dreams, you do.
Multi-dimensional matrices.
Yeah, in your wettest dreams, you and Pamela Anderson from the 90s are doing tensor calculus together and killing on the stock market. But let's come back down to reality.
So the gas simulation that I have, I'll post it. You can create particles, and then you can what's happening? And then you can turn on or off gravity, and then you can turn on or off a top boundary for this container. And again, it depends on what you qualify as a container. But there are like I just wrap it around. So like on a flat Earth, I guess what I'm trying to claim too is
a physical container, right? A physical container. I think everybody understands what that means.
What I want to try to say is that even on a flat Earth, if you just have downward little g acceleration, you don't need a top to the container. It can be an open lid, and it would still work. So this is not necessarily even a globe versus flat, thing. This is just saying that.
Yeah, we know this. We know that you can contain gas particles using electromagnetic fields, for example. So we know that. That's not new.
This is. I think that's true. You can contain it with electromagnetic, but what I'm trying to say is that even with just little g gravity, you don't need a lid to the top.
Right, but don't worry about this. The definition of gas pressure says it's a normal vector of the force exerted on the walls of a container, right? So if you don't have a container, you don't have pressure. You may be containing the gas using electromagnetism, but you don't have any pressure because there's no wall of the container. So anyways, just show us what happens when there's a bunch of gas particles without the container in your simulation, right? And then let us flip different switches, like,
Yeah, it's there. It's I just posted it. That's the whole.
For example, you could make the gas. You could have a setting for ionized gas, so positively or negatively charged molecules of gas, and then you would allow us to control different levels of electrostatic field, right? Different intensity, and see what happens to the particles.
But the what I'm trying to see is if downward acceleration or gravity, whatever you want to call it, if that is enough. I think that it's if we're not disputing whether or not gas can be contained by electrostatics, then.
Well, so let me help you. You're a glober, right? So you kind of believe in Einstein and the equivalence principle, right? So you don't need to argue with us about gravity. You can just say, imagine a box full of gas, right? Contained. Now imagine you open the top, right? Well, gas is going to come out. But now imagine that you accelerate the box, that's the equivalence principle, at 10 meters per second squared upwards in the direction of the open wall. Now imagine you accelerated more, right? 20 meters per second squared, whatever, 100. What happens to the gas, right? Will it form a gradient just because of the acceleration? Like you could simulate this as a thought experiment, right? That's what Einstein did in his head.
You can try it right now. Exactly what you described there. That's what I did.
Right. So basically, you could title this "Equivalence Principle and the Effect of Acceleration on a Slightly Open Container Full of Gas." Right. You could write a little paper here. We're going to review. We're going to be your peer reviewers. I mean, by we, I don't mean me because I suck, but people like Indio. And we're going to go from there.
Sure. I don't know.
I'm doing a peer review of your performance right now. It's quite laughable.
It is. I'm laughing my balls off.
Peter's a fake flat earther trying to pose. He's actually here to run interference so that we don't talk to you and that he freaking gums up the works. He thinks he's clever, but he's not.
The person who I'm talking to is not a real flat earther?
No, he's not.
Oh, shoot. Well, I got trolled.
Not at all. He actually was in a group called Globe 46 that tried to take us down on the politics server. Not take us down as in get us like banned or kicked off, just like, whatever. Defeat us or whatever they thought.
I see.
Yeah. He's not just a globe earther. He's an anti-flat earth globe earther that has spiraled so bad. Now he runs around pretend to being a flat earther. So his reasoning is he is sick of bad flat earth arguments. And since he is a newly minted flat earther, he's trying to fix everybody's arguments.
I see.
That's his
I was suspicious.
That's the last stick I heard.
When he brought up the upward acceleration thing, because wasn't that something that was on like the Flat Earth Society, that they thought that the Earth was accelerating up at 10 meters per second squared?
Yeah, Einstein wrote about it apparently, that the Earth would be equivalent to a disk accelerating up at 9.8 meters per second squared. That's kind of where that comes from, that idea. But nobody here believes that shit.
Yeah. This is always a question that I've had. Do you think little g is real? Like, what do you think of?
Yeah, I think small that's real. Yeah, sure.
Okay, yeah.
To know that empirically, we don't need any theory to know that.
Right. So, do you think that means that we don't need a lid to the container of the Atmos then?
Well, see, that's where it gets crazy because if you look at the kinetic theory of gases, there's no g in any of those formulas. So when we try to predict using physics what gas behavior is, we don't use g. We ignore it.
Right. But the kinetic theory of gases is accurate on small scales, but if you want to predict gas pressure at large scales, and like if you want to predict the gas pressure in the atmosphere, then you need to incorporate the hydrostatic equilibrium, and in order to get the.
Who told you that? An astronomer?
No. This is just like the way we.
You see the problem there, though, right? Is that hey, in the lab we can do all these things. Oh, we can't do that, and our theory that we've gotten from empirical experiment, it can't extend to explain the atmosphere. So we're going to come up with a different theory.
But we can explain, but we can test the accuracy of like the barometric formula or other more advanced versions of it, because we can test air pressure at different altitudes.
Yeah, but it varies, so it's kind of.
But it does vary. It does vary with temperature and things. But like airplanes need to know, like, so airplane altimeters use barometric pressure to know how high they are. So they need to know with high degree of accuracy. And it turns out that altitude has a much greater effect than temperature at higher scales, and that's because of the barometric formula.
High degree of accuracy. I would say they need to know it good enough for practical purposes. I wouldn't want to test your theory of barometric pressure flying an airplane. How accurate is it? What's the precision of our model? Oh, 10 meters, crash.
But obviously, if
you're not testing it to that level of accuracy, buddy. I mean, there'd be a lot of dead pilots.
But if you're close to the ground, then you are going to be using other measures other than like you're going to be using other measures than just your barometer to know your altitude. But when you're really high and you can't see the ground, then it's useful to use barometric pressure to use like the standard understanding of the pressure in the atmosphere to tell how high you are.
Well, I think they would know from the performance of the aircraft how high they are.
Yeah,
but within a pretty degree of certainty, a difference of 1,000 miles at 50,000 feet or 1,000 feet, right? The accuracy. Say you don't know within 1,000 feet how high you are. That doesn't really matter at 50,000 feet. You're in no danger of like smacking into the ground or hitting a meteor.
They need to know it precisely because it will impact performance. Like it's good to know, like, okay, we are at 35,000. We should stay here. And that's what the altimeter is for. And the altimeter is based on, it's like the idea of.
Yeah, I understand. I just don't think the method is that precise. Okay, I just think it's good enough for practical purposes.
There's an international standard for how how pressure changes with the atmosphere that relies on.
Yeah, I understand that. I understand all that, but like, how are you going to test that precision? You understand? Like, my altimeter says 50,000 feet. Okay, great. Am I going to drop a tape measure?
You could
see
use
if I'm at 50,000 feet.
You could use.
Yeah, that is an alternative method they use. They do use radar. I don't know what the precision of the radar is off the top of my head. Say a problem is like it doesn't look straight down; it kind of looks up at an angle. So.
Yeah. So this is kind of a side argument because.
Well, I'm only bringing it up. I'm not trying to I'm not trying to give you shit. Because some Gold Earther sent me a paper with like 5 different models of the atmosphere, and then they come to the end where they're going to try and validate one of these models, and they're like, "Well, it can't really be tested. We just have to go off the U.S. Standard atmosphere model and compare our models to that." So it's not just me blowing smoke; it's in a paper that someone sent me.
I think that we just have very good reason for the barometric understanding of the atmosphere to be the case. And like in this simulation, when you have gravity, gravity turned on, and you have a bunch of particles bouncing around, they just like I don't have the barometric formula encoded in this simulation or anything, but they form a gradient that we would expect from the barometric equation. They form that gradient just from simulating collisions between these particles.
Okay, I've already seen one of these, but
yeah,
no one can actually. The problem is demonstration that it's possible. Ultimately, you can have whatever theory you want, whatever hypothesis, whatever you want. Eventually, it's going to have to be empirically demonstrated in nature. That's the problem.
Yeah, I think that the accuracy we do have, airplanes rely on the barometric.
You seem to be not an empiricist.
Yeah.
Well, I mean, I'm just being honest. We encounter 2 types of people, pretty much. Mm-hmm. People that go with the empirical evidence, what's been tested and shown in nature, and then people that are more like lean towards the theory, hypothesis, physics models, blah blah blah. Right?
Mm-hmm. Mm-hmm.
Regardless of what your stance is, if you want to call it science, it has to be tested empirically. It can't just be like theory. Oh, we have a model of gas, blah blah blah. Great. Eventually, you're gonna have to go into the lab or in nature and test it, right? Would you agree with that? You have to verify it at some point. Okay.
Yeah.
So I mean, you can come up with, hey, we have a model. I made my good old gas particles take hyperbolic arcs due to 9.8 meters per second squared. Eventually, you're gonna have to go into nature and test it.
Yeah, I
I think
personally
that's
don't have
fair.
the means, I don't have the means to test it, but I did live in Colorado, and I felt the air, being the air getting thinner the higher I was. Even in the summer, even in the winter, I felt, air getting thinner as I went higher. So that's, I guess, as close as I've come to testing it. And that's an instance where the temperature doesn't seem to be the cause of it. It seems to be the altitude.
Yeah, I mean, gas pressure gradients exist inside a container too. You know that, right?
Yeah,
Yeah, they're not, as
but
long
I
as they're
don't
not
think.
static.
But they
But I'm
don't
liking your
need.
little mirror
They
thing
don't need.
because I'm looking at this and it's not a symmetrical reflection in your little mirror app.
It's no, I agree. It's there is distortion. There's especially at the edges as you zoom
You're gonna
in.
turn a mathematical physics PhD into a flat earther. You know that, right?
What'd you say?
You're gonna turn a dude with a PhD in mathematical physics into a flat earther with this.
Really? Okay.
You really helped me out, man. I should freaking give you a freaking. I helped out India roll or something. Because I had a debate with a PhD in mathematical physics, and my evidence was the symmetry of the reflection in the Bolivian salt flats. And he asked me if I did out the math, and then I gave him the math, and he was like, "Well, that's not how we see." I said, "So you want it in homogeneous coordinates?" He was like, "Yeah, you did it for me." So
Well,
he's gonna be a flat
where
earther now. It's gonna be great.
Yeah. Did you take a screenshot and kind of? I didn't actually implement that. Did you flip a screenshot or something to see?
What do you mean you didn't implement it? I clicked it. It worked.
Um, well, I
You
guess
didn't
I guess
implement it.
there's
Taking a bunch
a
of screenshots so far.
yeah. Um, the question is, if you take one of the pictures of the Bolivian salt flats and you compare it to I mean, the distortion is just very slight. It's a very, very slight amount of distortion. It's only at the edges that it's really visible to
Yeah.
the naked eye.
Well, I can see it definitely in your simulation easily.
Yeah.
It's not even difficult.
How high are you? Or if you can just link
2
the
meters,
URL.
1 meter.
Yeah. I was not able to perceptibly see it.
I look at
Unless I
this
was
shit all
really
the
zoomed
time.
in,
Maybe
but
that's the difference. I mean, one thing you can do, right, is you can try to use the horizon, and like I did measure difference in distances. So if you measure from a point on the horizon, pixel count, to some point on like a cloud, up and down, they won't match up. That's another way.
no, I agree that there is distortion. That if you measured it in ways like that, or if you flipped the image, you could see some distortion.
Yeah.
But I don't think it's when I've seen pictures of the Bolivian salt flats, they're usually not zoomed in, and I've never actually I haven't flipped one to see what the distortion is like. But we definitely we wouldn't expect it to be super obvious distortion to the naked eye.
Yeah, but you'd be visible. Would
It'd be
certainly be
visible.
visible. That was what the contention was, is whether the
Yeah.
symmetry would be visible, the break in symmetry, and it certainly is. And then so I debated this guy. His name is Dr. Blitz, PhD or something. I don't know if the PhD man. Anyway, he was on TikTok. He's got like 1 million followers or some shit. Anyway, I told him, I said, hey, when you flip the image, they overlay exactly. And this dude flipped the image freaking horizontally instead of vertically, or did something like that. This dude does have a PhD, dude. It's freaking almost embarrassing. The point is that at the end I said, so if I show you that there'd be distortion on a globe, and that the reflection in what's being reflected is not symmetrical, you'll be a flat earther. Did he say yes? I think he said yes. So that'd be great.
Yeah.
Either way,
I haven't
I have
actually.
to
I
jump
need
into
to.
one of his streams.
I need to look at some of these images. I guess I feel like it would be for one, it would have to be really long ways and ideally zoomed in so that you could see the distortion. But yeah, I'll have to try flipping one.
I got one I flipped. Hold on, in FU. So hold on, I'll show you. So here's the image that I showed him. Oh, Sasha got a nice one. There's one with a sunset too. That's fucking badass. But the water's a little rippled, so.
Okay, yeah, I see.
So I'll show you. The horizon isn't exactly in the middle, so you have to line up the horizon. You're gonna have some over. You'll see. Hold on, I'll show you.
Ideally, what we'd need is like clouds that are far away.
Well, look. You see what I posted with the red X? Right?
Yeah.
Dude, it's like put the arrows. So like you have a person there. The tips of those arrows are right at the bottom of his feet, and you can see the horizon divides it right in the center.
Yeah.
So this little box, right? You can find the center of a box by drawing lines between the diagonals, and you'll find the exact center of the box. So the corners of the box meet clouds. There's a cloud on the top, a cloud reflected on the top and the bottom in the same place. So I just made this little box so I could find the center, and it also meets exactly on the horizon. So there's a bunch of different ways you can measure whether the image is actually symmetrical. You don't have to just eyeball it.
Yeah.
Now there can be alterations because of tilting the camera and shit. You can get like, I wouldn't say it wouldn't be symmetrical, but problems when the horizon isn't exactly in the center. There's problems when it's not in the center of the image. As you can see in the image I posted, you can see some excess, right? Excess in the top and bottom because the horizon isn't in the center of the frame in the original image. Right, so I have to line them up to flip it. I have to flip one, line up the horizons.
Yeah. So when I zoom in my simulation, I have to be at like a 15-degree FOV and be able to really easily see clouds at the very distance, and you can see that some of the clouds are not reflected where in the same place as the horizon. I just don't think that we have enough detail in these photos to notice, because the distortion in the near part of the image is like nil. Like I can't visually see anything, and I can only really see really far away.
Well, I mean, I wouldn't call it nil. First of all, it's not really nil because if you look at if you look in, well, I'll just show you what I'm looking at. This is a screenshot I took. This is the full frame that was shown. I drew X to denote the center, which way the camera's pointed. Okay, so as the goal would have a horizon dip. I couldn't get the fucking.
It looks like your altitude.
I couldn't get the angle. Yeah, I couldn't get it exactly. I turned the mouse sensitivity down all the way down too.
Let me.
And I couldn't get it at 0.
Let me see if I can do that. So if you zoom in, something that could make it easier. If you zoom really far in, you can zoom by scrolling. If you zoom really far in, then you can put the cursor right at the horizon and then zoom back out and it'll stay there.
Oh yeah, that's a good trick. Yeah, but the horizon should be dipped, right? So the horizon isn't going to be at 0.
When the observer is really low like this, like a meter off, then the dip from the horizon is going to be extremely small.
So, but I don't need to be zoomed in to see that they're not symmetrical. It's pretty obvious to me. I mean, maybe it's not obvious to you, but it's very obvious to me. Maybe because I look at like this type of shit going on 10 years and like just looking at an image and looking at the horizon, looking at the sky and the ground is kind of like second nature at this point. Done it probably fucking thousands of times at this freaking point. Jeez.
Yeah.
But I can see it's not symmetrical. I can just look at the horizon boundary and see where the ostensibly the water, the simulated water, isn't the same as the sky in a bunch of places. It's not like just one place.
Yeah. If I will say, because of the way because we're limited by the resolution of the screen, if you zoom in and out, you'll see that some pixels leave and some pixels come back, and it's just a rendering artifact.
Yeah, I noticed that. Yeah.
So
it also does it when you rise in elevation. That's a weird. If you look at the horizon, if you change the elevation, like go up and down, and just look at the horizon, the way it kind of like unfolds is kind of weird. Are your clouds curving too? Are your clouds a sphere?
The clouds are a sphere, yes.
Yeah, okay, maybe that's it, yeah.